Hi and welcome, my name is Thomas and in this episode we'll be looking at challenge number 8, bypassing the Frido Sleigh CAPTEHA. Not a captcha, we'll see why in just a bit. So what do we need to do? Help Krampus beat that Frido Sleigh competition, and for hints we can talk to Alabaster Snowball in the speaker unpreparedness room. So we're there already, and so let's talk to Alabaster. His problem is he seems to be stuck in a different shell than his normal bash shell, so we need to try and help him out with that. So log in as the user Alabaster_Snowball with a password of password2 and land in a bash prompt. Let's see if we Alabaster Snowball and then password 2. That is not a bash shell for sure. So let's back out of that and take a stab at it again. So first, to solve this, let's look at the contents of passwd. Alabaster Snowball definitely does not have bash set as his favorite shell. Okay, so now let's look at the properties of that specific shell. Okay, so it seems to be world writable, so I should be able to copy over bash over that. So let's do that, but it fails, and the reason why it fails is because if you look at the file attributes, not the file permissions, you'll see that the file is marked as immutable, which means that regardless of what the file permissions might be, there's no way you'll be able to replace or change that file. Now, one of the things that we do have access to, luckily, to fix this is if you look at our sudo permissions, we are able to use the chattr or change attributes command. And so what we're able to do using this is we can basically say, well, remove that immutable flag from that particular Nyanshell. So we do that and we look at those attributes again. So now that I has gone away. And now we can actually try and copy over bash again, which now works. So let's try logging in as Alabaster, because now Nyanshell basically is replaced with a copy of bash. Alabaster. Learn to type, Thomas. Alabaster Snowball. Yeah, there we go. And password 2. And now we are in bash. Perfect. So that's done. Let's finish that conversation here. Looked at the CAPTEHA challenge required to enter. Heard there was a CrinklCon 2 talk about machine learning to defeat challenges like this. Okay, awesome. So objectives, the Frido Sleigh contest. So let's open up that contest page. There we go. Okay. Perfect. And then one of the hints was a talk about machine learning. So again, for this challenge as well, you'll find a major hint in one of the CrinklCon 2 talks by Chris Davis, which talks about machine learning and how you can use machine learning for certain cybersecurity cases. It also comes with a GitHub repository with a demo, basically, related to that presentation. So that's something we're going to be using as well. But let's first look at that competition page, right? So Frido Sleigh, free Frido Sleigh cookies for life, which sounds awesome. And so we can fill that in, but at the end you'll notice that there's not a captcha, but a CAPTEHA. And if I actually look at what that is, it's basically a test to distinguish elves from humans. Elves are apparently very good at clicking on and identifying holiday related items. Humans are apparently not quick enough, and I'll show you that right now. So if I click on I'm not human, you get about 5 seconds here to select Santa hats, ornaments and candy canes, and if you're not quick enough, you fail. So there's no way for me to kind of do this manually. So that's where the machine learning portion comes in. Okay, so looking at the demo material from Chris, you'll see that it provides basically an example of how you can use a whole set of images to train a machine learning setup, which you can then use to identify other images and say, hey, with a certain certainty, it's this type or that type. And so there's two scripts basically that the demo provides. One is the training script, which will basically use a folder with images as input in subfolders that define the categories, right? So like if we go into training images here, you'll have the category apple and banana. Apple will have all apple images, banana will have all banana images, and then you can run, once you've trained your machine learning setup, you can then, or your model, you can basically then go and use some of the unknown images and run those through the predict images using trained model script. And what that'll do is it'll basically grab all of those files, it'll go and try and match them up or take an educated guess, like what to predict them basically using machine learning algorithms to say, hey, it is a banana or it is a apple. Now we're facing the same thing here, right? The thing though is that normally we should have received, let's see if we can grab it from the talk with Krampus. Where's Krampus here? There he is. So Frido Sleigh, see if there's anything else. Not yet. Okay, let's head over to Krampus again first, because Krampus normally should give us some images. CAPTEHA. Ah, there we go. That's what I needed. So 12,000 images and an API interface that he's already written or downloaded somewhere. Now, let's look at those images. So we have training images, and they're separated by category, just like in the demo by Chris. It's candy canes, Christmas trees, ornaments, presents, Santa hats, and stockings. So we can use that together with Chris's script, basically, to do the same kind of a training. To build out that model and train that model so it can identify those types of Christmas ornaments. So once we've done that, right, once we've trained that model, and the way you would do that is by using the following command. Let me copy and paste that here in its most basic form, but we'll make an adjustment there. So we would say Python retrain, because that's the script that Chris provides, and then provide it with the image directory, which is training images in our case. Now the problem is that if you use the default version of the training script, it actually works for higher resolution images than the ones that we need for this CAPTEHA challenge. Our images are way smaller than what Chris's script actually uses, and so let's look at actually let's use the GitHub repository for that. Let's see, there we go. So let's go to retrain. So one of the things that this default uses is it uses a default model basically. And one of the things that you'll notice is if you use that default model, it'll work fine. But the problem is if you try and run that trained model, it'll take too long, or it might take too long, depending on your hardware, might take too long to actually get through all of those 100 images and predict them. So you need to basically define or use a different model, a machine learning model in this case. And the reason why that works is because, like I said, the images that are used in the CAPTEHA, they are lower resolution than the ones that are used in the default model. The actual script itself speaks about that as well. It actually gives you some information. By default, the script will use highly accurate but comparatively large and slow Inception v3 model architectures. That's going to be a resolution of 299 by 299, I believe, in the original script. You can also define a different MobileNet model, which will let you train using smaller resolution images, which is what I did for solving this challenge. So looking at the original script that we got from Krampus, it basically does the following. So it sets up a session to download the information from that website, right? It pulls from this particular endpoint. We can do the same thing, basically to show you what that looks like. Cookie contest, and then if we hit the API endpoint, there we go. You'll basically get back a list of image information, which contains the base64 encoded image data, and it'll also include a UUID for each of those images. What we need to do is submit the correct UUIDs for the images that match for that particular test. So once we pull down those images and we also define which types we need, which is the 3 categories that we get per test, we then do some machine learning stuff, and then we submit the final answer, right? The final answer is going to be the image UUID as CSV formatted data. That's going to be submitted back, and then we'll get the response, and hopefully we'll have passed that CAPTEHA test. And then once that's done, we have our user information where we will submit our actual email address, and then it'll try submitting as many options as possible until we basically win. It's going to resubmit that form, until we've won, until we've got confirmation. Now, looking at the scripts from Chris again, so we have a script to train, right? But we want to use a different mobile net model because we want to train with less high resolution images. So the one that I've used for that is the following. This is the command that I used. So retrain with that image directory with those images, and then use the mobile net model, which is the 128 version. 128 basically is the resolution here. That's more than adequate for those images, and that should give you the correct training information, correct trained data. I'm not going to run this here because it takes a while to run, so I've already trained this model, so we should be good to go. I will be looking at the original script from Chris, so to actually run or match those images or predict those images. So it's called predict images used train model, and what that does is, I'm not going to go over each of these different functions, don't need that all that much. We'll basically be copying those over into our own script, or the script that we got from Krampus. What we will be looking at is this particular code here, just really quick. So we basically load in the images. We're going to have to change that, obviously, to make sure that we get that information from the CAPTEHA and from the web request, not from a file directory. For each of the images, we're then going to start some threaded activity, and we are going to be predicting that image using image thread. Target is going to be the predict image function, and these are going to be the arguments that we're going to pass on, which is going to contain both the image information and some others, which we'll need to change here, obviously, to also include the UID. Once all of that prediction activity has been done, we'll have our prediction results, and then we can loop over those prediction results and get the information that we need. So translating that to our final script, it'll basically look like this. So first of all, we have the same functions as Chris's script, right? So anything that predicts the image, loading the labels, that's all the same, except for obviously adding the UUID in predict image, because that's information we need to put in there. Secondly, we also need to change the default 299 image resolution to 128 to match our new model. And then if we go over the actual main function, we'll see that as before, we'll be doing that web request, that get request to get the CAPTEHA. We'll get our types as well. And once we have that, we're going to loop over each of the images. For each image, we're basically going to be looking to predict that image. Once we have it predicted, once the whole queue of 100 images has been handled, we have our prediction results, and then those prediction results can be submitted back as an answer. So this is where we have loop over all of those predictions. If the prediction basically matches what we're looking for in terms of a type that we need to select, we're going to add that UID as a correct answer, and that's going to be added to our answers list. Then our final answer is basically going to be the string of all our UIDs concatenated and separated by a comma. Now, once we have that, we can make our web request with our response, our answer to that CAPTEHA test. And this is basically the same code that Krampus provided us previously. Once we have a match and once it's solved, we can then submit that as... we can keep spamming basically that form until we get confirmation that we won. So if we run this, let's see if I can get that going. What's my script name? Not retrain, CAPTEHA API. Python CAPTEHA API. Let's do this. Okay. Hopefully it works. So machine learning setup. So it's downloading the images, processing each of the 100 images. Before I go forward, I'll scroll up and pause for a second. So waiting for all the threads to end, which means that it's predicted all of those images. We're looking for presents, Christmas trees, and canes. So looping through those prediction results, we'll see that these images basically match the things that we're looking for. And then we submit the answer, we get a response back that it's solved, and then it starts submitting that form over and over and over again until finally we get our results back and say that, hey, we've won, and we received an email. Now, let's see. I'm gonna grab that email. Wait for it to arrive first. There we go. So let's see. Opening up that email, just made a screenshot of that. This is the code that we're looking for in our confirmation email. So now that we have that code, we can actually submit that as an answer in our badge. Bypassing, there we go. Let me make a copy of that code. There we go. And submit that, and that is correct. Awesome. So now we've solved that, we can talk to Krampus again. And now he's flashed our badge with a teleportation setup that allows us to actually use the steam tunnel vents to go between each of these different areas. So that'll hopefully solve that problem of me having to hop around from one end of the university building to the other, because I forgot to click on a certain avatar or certain NPC and get the full conversation. So hopefully that won't happen again, or at least we won't be spending or wasting too much time doing that again. Okay, so let's click on Krampus to finish up all of the rest of that conversation. Let's see, yep, there we go. And then now we can actually handle Objective 9, which is going to be for the next episode. As always, thanks for watching. I hope it was interesting, and I'll see you on the next episode. Have a great day. Bye.